So, good morning everyone. My name is Patricia Nicole M. Alada and I am with Iskak, Baundi, and Abdul Rahman. So, we are assigned to tackle about compressive strength of cylindrical concrete specimens. So, the compressive strength of the specimen is calculated by dividing the maximum load achieved during the test by the cross-sectional area of the specimen. The results of this test method are used as a basis for quality control of concrete. So the purpose is to determine the compressive strength of cylindrical specimens such as molded cylinders and drilled cores. So anything related to compressive strength of concrete, the main purpose or the main significance is to have the quality assurance measure. So that's the use of the experiments in general. So significant and use. This test provides the compressive strength of concrete, which is used universally as a measure of concrete quality. Apparatus. Loading machine with two hardened steel breaking blocks. The upper block is spherically sealed and the bottom block is solid surface. So as seen in this picture, the loading is going to be applied by the computer. So that's the apparatus that we are going to use in this topic.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ismail A. Iskak from BSc 3A, and today I'm going to discuss my given part in our topic, compressive strength of cylindrical concrete specimen. So this is my topic. So test specimen. The standard specimen size used to determine the compressive strength of concrete is 152 mm or 6 inch diameter by 300 mm or 12 inch high, for a maximum aggregate size up to 50 mm or 2 inch. The smaller specimens, such as 102 mm or 4 inch diameter by 203 mm or 8 inch high, are sometimes used but they are not ASTM standardized. So sinasabi rito na may dalawang klase ng concrete compression strength, which is the 6 inch by 12 inch, and the smaller specimen is 4 inch by 8 inch, but the smaller specimen are not qualified in ASTM standardized. So next is conduct the compression test on the moist cured specimen directly after removing them from the curing room. Test specimens must be moist when tested. And next is neither end of compressive test specimen shall depart from perpendicularly by more than 0.5 degree, approximately 3 mm inch or 0.3 meter by 1.8 inch in 12 inch. And if the end of the specimen are not plane within 0.05 mm or 0.002 inch, they should be capped with sulfur or capping compound. New print cup may be used in figure A.39, but they are not ASTM standard. The specimen age at time of testing should be 24 hours plus and minus 0.5 hours, and 3 days plus or minus 2 hours, and 7 days plus or minus 6 hours, or 28 days plus or minus 20 hours, or 90 days plus and minus 2 days. And ito yung figure 8, 3.39. So, figure A.39. Ito yung sinasabi kanina na new print cup used for capping. So ginagamit itong new print cup para maging plain, or kung hindi plain yung dulo ng ating concrete, kailangan natin gamitan siya ng cup na ito para maging stable or maging 0.05 inch yung dulo niya. So Neoprene cups or pods are accurate, efficient, and economical for compressive strength tests of concrete cylinders and serves as a faster and safer alternative to sulfur capping. Gilson's unbanded neoprene pods are sold as single or in packs of 12 only for 4 and 6 inch, and available sizes are 6 inch, 4 inch, 3 inch, and 2 inch diameter cylinders. Select a durometer rating based on the design strength of the concrete specimen. So ito yung ibig sabihin ng neoprene cup or yung ginagamit nating pads sa ating concrete strength test.
To learn about the test procedure, number 1 that we should always remember is to measure the diameter of the test specimen to the nearest 0.25 mm or 0.01 inches by averaging two diameters measured at right angles to each other at the middle height of the specimen. Number 2, adjust the bearing blocks into position. Number 3, clean the faces of the bearing blocks in the specimen. Number 4, carefully align the axis of the specimen with the center of the thrust of the spherically seated block. The last number is to apply the load continuously and without shock. For screw-type machines, use a rate of loading of 1.25 mm per minute or 0.5 inches per minute. For hydraulically operated machines, apply the load at a constant rate within the range of 138 kPa per second, 20 psi sec to 50 psi sec during the first half of the anticipated loading phase. A higher rate of loading is permitted. No adjustment in the control of the testing machine should be made while the specimen is yielding rapidly immediately before failure.
Test method for compressive strength of cylindrical concrete specimens. First is care must be exercised in the interpretation of the significance of compressive strength determination. By this test method, since strength is not a fundamental or intrinsic property of concrete made from given materials. So, kailangan natin yung mga pag-iingat sa paggawa ng specimen. Before tayo gagawa ng specimen, kailangan natin alam yung standard na procedure na ginawa ng engineer. First is, kapag sa mixing, kailangan natin ng balance. Alam natin yung right balance ng mixing natin, and also the shape and size. Kapag oversize naman, kailangan din natin yung size natin is magkakasya and suitable and compatible sa machine natin. And also yung shape natin. Malay mo kapag gagawa na tayo is akala mo cylindrical, kaya hindi pala is nagiging square na pala siya. And also sa batching and sa fabricate, and also the age sa pressure. The result of this test method are used as a basis quality control of concrete proportion. So kapag natapos na natin yung test natin, kailangan natin yan. Gagamitin natin yan as a basis quality control. Kasi kapag natapos na natin yan, kapag nalaman natin yung lakas kaya ng isang specimen, mixing and sa mga proportion. Next is the individual who tests concrete cylinder for acceptance testing shall meet the concrete laboratory technician requirements. Siyempre yung mga nagtitest yan sa laboratory, meron yung mga training before sila mag-test ng isang cylinder or isang specimen is alam nila kung anong gagawin nila. May practice na sila. And also, kasi bago nila ito ginawa, paano na sila, ginawa nila muna yung requirements ng C1077. Yung C1077 is the practice for agencies testing concrete. And concrete aggregates for use in construction, and criteria for testing agency evaluating. So, concrete cylinder compression test. Make sure both faces are flat and level, and measure diameter and cylinder. Of course, kasi nire-record natin yan and also kailangan natin i-sure na yung both faces ng isang specimen cylinder is flat, or di kaya kung level, kasi alam naman natin yung iba kasi pangit naman pa tingnan natin kapag ganito paslanting yung isang specimen. Hindi na natin yun hindi yun magiging compatible sa machine. So ganyan. So sa pag-measure ng diameter is ganyan. Every side is i-measure natin sa paggawa ng height and also the diameter. So diameter i-measure natin yung sa east to the west and north to the south. Kailangan natin yan basta cross-sectional yung pag-measure nito. And the height. So, sa pag-record ng ating sa pag-record ng ating one is also record the length and the diameter, sabi ko kanina. So, kailangan natin is record the maximum load of isang specimen, and also the type of fracture. Meron kasi tayong iba't ibang type na iba't ibang fracture kapag na-test na natin ang isang specimen. But before that is what can affect the strength. Kaya nang sinabi ko kanina is also na-effect na yung strength ng isang bagay, ng isang specimen sa isang size of specimen, shape, batch, mix, age, and pressure, moist curing. So sa curing kasi kailangan always yung isang specimen bago natin siya ikon sa test procedure is kailangan always yung nasa always siyang moist, always siyang nasa tubig before gagamitin para sa test. And also the temperature, and also the mix procedure. Kapag sa mix procedure naman, kailangan din natin ng right balance ng isang specimen. Kasi sa napanood ko sa YouTube, and also naman sa atin, alam naman natin kapag sa mixing is kailangan hindi naman masyadong maraming tubig, hindi naman masyadong sand, kasi hindi magkakaroon ng hindi masyadong lalakas yung isang specimen. So verifying that no individual diameter differs other diameter by more than 2%. So before tayo magte-test ng isang cylinder or isang specimen, kailangan natin linisan muna yung yung machine natin or testing machine natin, and also the lower bearing blocks. Kailangan natin i-wipe. So the next is type of fracture natin is meron tayong cones. Meron tayong cones in both ends. Parang yung kapag i-test natin yung isang bagay ay yung specimen pa-X siya. Kumbaga parang nagiging cone siya. Pa-X yung nagiging fracture ng specimen. And also parang ganito siya. Ganyan. also basta meron tayong one, and also kapag bones on the one ends, meron tayong vertical cracks, diagonal fracture, side fracture, and side fracture with pointed head. Yun, meron tayong 6 types of fracture about testing this specimen. Kapag matest na natin yun, meron iba't ibang fracture, so malalaman natin doon kung ano yung problema sa specimen, ano yung dapat natin i-improve pa din. And sa kapag sa machine kasi, kapag mag-test na tayo, i-apply natin yung force ng isang compressive, isang machine na until mag-failure yung isang specimen, hanggang mag-crack na siya. Yun ang i-base natin. Tapos after that is mag-crack na yun siya, i-record natin yung ano yung maximum load ng isang specimen. Pag mag-break na siya, yun, stop na natin. Also na yun. Kasi nire-record naman ng isang machine yung isang force. Kumbaga, gina-indicate din ng isang machine kung ano yung kaya ng isang specimen na yun, na force. And also yung i-record natin yan. So, calculating the compressive strength for concrete as a F prime C is equals to P max all over 8. Yung P is pounds, and also the maximum load, and also the A is area. So, yun yung given natin. For example, yun ang given natin kapag i-measure natin yung isang specimen is yung other side is ang diameter niya is 4.1 inch, and yung other side naman is diameter niya is 3.99 inch. So sabi ko sa inyo, kapag kailangan yung magkaiba ng diameter, hindi siya lalagpas sa 2%. So for example, yung maximum load natin is 50,000. First is gagamitin muna natin, ano yung kukunin natin? First, kukunin muna natin yung area. Yung area natin, kukunin natin ito. Ang formula niya is area is pi r squared. So, paano natin makukuha yung r? So, yung r is d over 2. Yung kanya. Para makuha natin ang average diameter, kuha na natin is D plus, i-add natin yung D plus D2. So substitute natin, so yan yung 4 yung answer natin. So yan yung magiging R natin, magagagamit natin yan. So nakuha na natin ang area natin is 12.57 inch squared. So yeah, i-apply na natin. So ito na yung magiging, so ang answer natin is 3,977.7, or pwede natin siyang i-round off sa nearest tens. So ang nearest tens ng 3,977.7 is the 3,900. So PSI.
Everything you need to know about concrete strength. So kindly listen, because in this part, we will take a look at the different types of concrete strength, why they matter, and how they impact the quality of concrete projects. We will also present to you the differences of strength between traditional concrete and the newer, innovative concrete technology, which is the UHPC, meaning Ultra High Performance Concrete. So concrete is considered by many to be a strong and durable material, and rightfully so. But there are different ways to assess concrete strengths. Terminology, concrete strength properties and why they are important. So, compressive strength of concrete, this is the most common and well-accepted measurement of concrete strength to assess the performance of a given concrete mixture. It measures the ability of concrete to withstand loads that will decrease the size of the concrete. So, the compressive strength is tested by breaking cylindrical concrete specimens in a special machine designed to measure this type of strength. So, it is measured in pounds per square inch or PSI, and the testing is done according to the American Society for Testing and Materials Standard C39. Compressive strength is important as it is the main criteria used to determine whether a given concrete mixture will meet the needs of a specific job. So, concrete PSI. Concrete footings and slab on grade typically requires a concrete of 3,500 to 4,000 psi. Suspended slabs, beams, and girders require 3,500 to 5,000 psi. So, traditional walls and columns tend to range from 3,000 to 5,000 psi, while 4,000 to 5,000 psi is needed for pavement. So, PSI measures the compressive strength of concrete. A higher PSI meaning a given concrete mixture is stronger, so that is why it is usually more expensive. But these stronger concretes are also more durable. So, in short, the higher the PSI, the concrete will last longer. So, concrete structures in colder climates require a higher PSI in order to withstand more freeze cycles. Compressive strength is usually tested at 7 days and then again at 28 days to determine the PSI. The 7-day test is done to determine early strength gains, and in some cases, it may even be performed as early as 3 days.
The tensile strength of concrete. Tensile strength is the ability of concrete to resist breaking or cracking under tension. It affects the size of cracks in concrete structures and the extent to which they occur. Cracks occur when tensile forces exceed the tensile strength of the concrete. Traditional concrete has a significantly lower tensile strength as compared to compressive strength. This means that concrete structures undergoing tensile stress must be reinforced with materials that have high tensile strength, such as steel. It is difficult to directly test the tensile strength of concrete, so indirect methods are used. The most common indirect methods are flexural strength and the split tensile strength. The split tensile strength of concrete is determined using a split tensile test on concrete cylinders. The test should be performed according to the ASTM C496 standard. So the flexural strength of concrete, flexural strength is used as another indirect measure of tensile strength. It is defined as a measure of an unreinforced concrete slab or beam to resist failure and bending. In other words, it is the ability of the concrete to resist bending. Flexural strength is usually anywhere from 10 to 15% of the compressive strength, depending on the specific concrete mixture. There are two standard tests from ASTM that are used to determine the flexural strength of concrete, the C78 and C293. Results are expressed in the modulus of rupture or MR in PSI. Flexural tests are very sensitive to concrete preparation, handling, and curing. The test should be conducted when the specimen is wet. For this reason, results from compressive strength tests are more typically used when describing strength of concrete, as these numbers are more reliable.
Water-cementitious ratio. This refers to the water of cement in the concrete. A lower water ratio makes for a stronger concrete, but it also makes the concrete more difficult to work. Kailangan natin kapag sa mixture, mixing cement and water, so paggawa ng specimen natin is kailangan natin yung right balance para ma-achieve natin yung desired natin na strength. And sabi dito is the lower water to cement. The lower water to cement ratio makes for stronger concrete. Oo, pero guys, mababa yung work ability niya. So it's difficult to work with. And also the proportioning. Ang proportioning natin dito is traditional concrete is made of water, cement, air, and an aggregate mixture of sand, gravel, and stone. The right proportion of these ingredients is key for achieving the higher concrete of strength. So, sa proportioning natin is also kailangan natin mag-adjust in every ingredients of this mixture. Kasi, hindi naman pwede marami dito, marami doon, marami sand, marami gravel. So, kailangan din natin proportioning, adjusting para ma-achieve natin yung higher concrete strength. Next one is mixing. Optimal mixing time is important for strength, while strength does tend to increase with mixing time to a certain point. Mixing for too long can actually cause excess of evaporation and formation of the fine particles within the mixing. Siyempre, sa napanood ko, meron tayong proper na pag-mix ng isang specimen. Pag mag-mix tayo, meron tayo speed dun sa kwan is 25 times ata yun. So, hindi naman masyado dapat matagal, kasi kapag masyado matagal yung pag-mix natin, parang naghihiwalay yung water sa cement, kaya nag-evaporate yun. Tapos yung formation ng isang fine particles is nasisira. And also kapag sa kuhan is kapag nag-mix tayo side by side yan, hindi ka dapat doon na nakatutok lang sa isang place. Dapat kailangan kung mag-mix tayo all over the mix natin. So, basta kailangan natin yung time is or i-less lang natin. Kung alam mo na pwede na yun, huwag mo na yung dagdagan nila, kasi mas magkakaroon pa ng problema kapag mas matagal yung pag-mix natin. And curing methods, the longer the concrete is kept moist, the stronger it will. So, sa curing method is kapag dapat always yung specimen, yung cylinder specimen natin is always a mixture para malakas yung kwan. Diba, pansin natin kapag nag-test tayo ng specimen is bago nila nititest yun, kinukuha muna nila dito yung specimen sa yung concrete sa tubig. And kaya always keep moist. Pero bago nila yun iti-test, punasan mo na lang. Pero punasan mo, kahit pinunasan mo, moist pa rin siya. Kasi kapag moist, mas malakas yung isang concrete specimen. And precaution must be taken by curing concrete in extremely cold or hot temperature. Siyempre dapat yung pag-cure natin is hindi masyadong malamig and hindi naman mainit. Kailangan warm lang. Yun lang.
So next is the hard facts, traditional concrete versus UHPC or ultra high performance concrete. A new concrete technology is available that has greater strength properties than traditional concrete across all strength ranges. This innovative materials is called ultra high performance concrete or UHPC, and it is already being implemented in many state and federal government infrastructure projects given in exceptional strength and durability. So next is UHPC is very similar to traditional concrete in its composition. In fact, roughly 75 to 80% of the ingredients are the same. So sa picture na pinakita ko, yung sa kabila is the regular concrete and sa kabila naman is UHPC. So ang pagkakaiba nila is ang UHPC ay mas pulido kaysa sa regular or the traditional concrete. What makes UHPC unique are integrate fiber. These fiber are added to the concrete mix and account for 20 to 25% of the end products. The fiber vary from polyester to fiberglass bar, basalt steel, and stainless steel. Each of these integrated fibers are created a progressively stronger end product with steel and stainless steel delivering the greatest gains in strength. So ang pagkakaiba or ang lamang daw ng UHPC sa traditional concrete ay yung fiber or the polyester fiberglass. And here is a closer look at how UHPC compared to traditional concrete. In tensile strength, UHPC has a tensile strength of 1,700 psi, while traditional concrete typically measured between 300 and 700 psi. In flexural strength, UHPC can deliver more than 2,000 psi in flexural strength, and the traditional concrete normally has a flexural strength of 400 to 700 psi. In compressive strength naman is the advanced compressive strength of UHPC is particularly significant when comparing to traditional concrete. While traditional concrete normally has compressive strength ranging anywhere from 2,500 to 5,000 psi, UHPC can have a compressive strength of up to 10 times than traditional concrete. After just 14 days of curing, UHPC has a compressive strength of 2,000 psi. This number increases to 30,000 psi when fully cured for 28 days. Some mix of UHPC have even demonstrated a compressive strength of 50,000 psi. So dito pinapakita rito na mas lamang or napakalaki ng kalamangan ng UHPC other than the traditional concrete. Simula sa tensile strength, ang UHPC daw ay merong tensile strength na 1,700 psi compare sa traditional concrete na meron lang siyang 300 to 700 psi. And sa flexural strength naman, ang UHPC can deliver 2,000 psi and the traditional concrete is nasa ranging from 400 to 700 psi. And compressive strength naman is the advance of UHPC in traditional concrete is napakalaki. Dahil ang UHPC, ang traditional concrete ay meron lang siyang compressive strength simula 2,500 to 5,000 psi. At ang UHPC naman ay 10 times na mas malaki ang compressive strength kaysa sa normal traditional concrete. And the UHPC is palaki ng palaki ang kanyang PSI pag nagiging fully cured ang kanyang process. And other benefits of UHPC includes freeze or thaw resistant. Studies have shown UHPC to withstand more than 1,000 freeze-thaw cycles, while traditional concrete begins to deteriorate in as few as 28 cycles. Impact resistance. UHPC can absorb 3 times more than energy than regular concrete. And other impact loading, UHPC was twice as stronger as regular concrete and dispersed up to 4 times as much energy. This makes the materials a great candidate for earthquake resistant bridges and buildings. And next is moisture resistance. Due to a higher density than traditional concrete, it is harder for water to penetrate in UHPC. So sinasabi rito sa freeze flow resistance ay ang UHPC daw ay kaya niyang magstand more than 100 Fisto cycles, which is the traditional concrete or the normal concrete is ang kaya niya lang is 28 cycles. At sa impact resistance naman, ang UHPC kaya niyang i-absorb ang 3 times more energy than regular concrete. So kung ang traditional or regular concrete is nasa first energy pa lang siya, ang UHPC kaya niyang i-absorb ang 3 times more than the regular concrete. And the UHPC daw ay mas magandang gamitin siya sa earthquake resistance tulad ng bridges and building. So mas matibay siya kaysa sa traditional or the regular concrete. In the moisture resistance, due to the higher density than traditional concrete, is sinasabi rito na mas ang tubig daw ay mahirap mag-penetrate sa UHPC or mahirap siyang mag-leak kaysa sa traditional concrete. And ductility, UHPC can be stretched out into thinner section under tensile stress, unlike regular concrete. Longer useful life, UHPC lasts more than 75 years versus 15 to 25 years for traditional concrete. Lighter weight, even though UHPC is stronger, less materials is required, so the end structure is lighter in weight, which reduce footing and support requirements. Concrete innovations such as UHPC outperform traditional concrete in all areas of strength, making it a smart choice for any and all concrete project. The reduced maintenance and increased longevity of UHPC delivers a win-to-win of superior strength and lower life cycle cost. And that is my report. Thank you for listening. Subscribe.
这一次我真的睡着了。